So yesterday in class we ended our notes talking about our vertical line test. We looked at linear equations, quadratic equations, and absolute value equations. So next we're moving on to our exponential equations. So these graphs, you can tell that they are curved. So look at the curve here on both of these graphs. So the two that are the most common for us are our exponential growth that's going up, and then we have our exponential decay, and you can see that it is going down. There's a product of constants raised to the power of independent variables. So that's kind of what it's going to look at. So let's look to see if these types of equations are going to form, if they are functions or not. So you can find your vertical line, and let's use our vertical line test. So anywhere I put a vertical line on these graphs, they should only touch at one point. And you can see that that is true for exponential growth. So it is a function. Now for our decay, let's try again with our vertical line to see if it will pass, and it looks like it will. Anywhere I put a vertical line on this graph, it passes our vertical line test. So this lets us know exponential equations are functions. All right, let's move down to our step functions. Now these are a little different. It's kind of hard to see, so I'm going to try to explain this a little better than what you can actually see. With our step functions, you can see here that we have a few points that are closed, and there are points that are open. I think it's pretty easy for you to see those. What I do want you to notice, though, is that these points are actually connected by a line. And on those lines are an infinity amount of points. So when you are using your vertical line test, let's say we put it here. Now this vertical line, as you can see, is going through a closed circle, and it's going through an open circle. So you kind of think about your inequalities. When you have a closed circle and an inequality, it is included in your solution. But if it's an open circle, it's not. So even though it's actually going through 2 points, it's going through a point that is included and a point that is not included. So this type of graph is actually a function. Now what I want you to be careful of, though, is if it goes through a closed circle, a closed point, and a line, then that's going to count as 2 points, and it will not pass the vertical line test. So the last ones at the bottom are unusual functions. These are graphs that you don't really see that often, but you can still use your vertical line test to see if it's going to be a function or not. So we can see that graph number 1, wherever I put a vertical line, it passes. But look at the second one. It does not pass the vertical line test. It's actually touching 3 points here. And then we have our last one. Wherever I put a vertical line, it should only touch 1 point. And it is a function. So now that you know the different types of equations to look for, let's go through practice 1 and determine if each one is a function or not. Press pause, and when you're ready to continue, press play. Check your answers for practice 1. If you missed any, go back and look at your notes again. The only one I want us to really go over now is number 8. A lot of people had a confusion about it in class. Notice, though, when I do my vertical line test, if I put it down the middle, it's crossing through 2 points on these lines. So it is not passing our vertical line test. If we move to a new spot, it is going through a closed point and an open point, but it's also going through an actual line, which is why it is not a function. Let's move down to practice 2. Give them a try. Press pause. When you're ready to continue, press play. Check your answers. Number 2 is not a function. It is a quadratic equation, but your y is squared. Number 4 is an absolute value equation, but your y is an absolute value. If you missed a problem, go back and look at your notes again. This is everything that we completed with our functions.